Web services testing and SoapUI. Quality is a key to success of service-oriented projects. Utilization of proper tools is important to the outcome of web service testing methodology. Being the leading open source web services testing tool, SoapUI helps to build robust and flexible automated tests in a productive manner. So let's take a look at what we'll be covering in this slide. First of all, the overview of some of the key characteristics of web services. The role of web services in SOA, approaches of testing web services testing challenges, the introduction to SoapUI, and much more. Web services are one of the key building blocks of service-oriented solutions. Because of their usage and importance in the enterprise applications, the project teams are expected to be knowledgeable and familiar with the technologies which are associated with web services and service-oriented architecture, SOA, also known as SOA. Service-oriented architecture and web services. Service-oriented architecture is a distinct approach for separating concerns and building business solutions utilizing loosely coupled and reusable components. Service-oriented architecture is no longer a nice-to-have feature for most of the enterprises and is widely used in organizations to achieve a lot of strategic advantages. By adopting SOA, organizations can enable their business applications to quickly and efficiently respond to business process and integration changes which usually occur in any enterprise environment. If a software system is built by following the principles associated with SOA, it can be considered as a service-oriented solution. Organizations generally tend to build service-oriented solutions in order to leverage flexibility in their businesses, merge or acquire new businesses, and achieve competitive advantages. To understand the use of purpose of SOA and service-oriented solutions, I'm going to cover a little bit of a case study, kind of like an example. So let's take a look at our case study. Let's say, for example, Chang & Co. is a large motor insurance policy provider located in North America. The company uses a software system to perform all their operations which are associated with insurance claim processing. The system consists of various modules including customer enrollment and registration, insurance policy processing, insurance claim processing, customer management, accounting, and service providers management. With the enormous success and client satisfaction of the insurance claims processed by the company during recent past, Chang & Company, which is our first example company, has acquired InsureCo Incorporated, one of its competing insurance providers, a few months back. So we're going to compare two little insurance companies. InsureCo has also provided some of the insurance motor claim policies, which are similar to those that Chang & Co. provides to their clients. Therefore, the company management has decided to integrate the insurance claim processing systems used by both companies and deliver one solution to their clients. Now, Chang & Co. uses a lot of Microsoft technologies, and all of their software applications, including the overall insurance policy management system, are built on a .NET framework. But InsureCo, the other company, uses J2EE heavily, and their insurance processing applications are all based on Java technologies. To worsen the problem of integration, InsureCo consists of legacy customer management application component as well, which runs on an AS400 system. So the IT departments of both of these companies, as you can imagine, face numerous difficulties when they try to integrate the software application in Chang & Co. and Insure Company Incorporated, so both of them. They had to write a lot of adapter modules so that both applications would communicate with each other and do the protocol conversions as needed. In order to overcome these and future integration issues, for instance, the IT management of Chang & Co. decided to adopt SOA into their business application development methodology and convert the insurance processing system to a service-oriented solution. As the first step, a lot of wrapper services, and this refers to web services which encapsulate the logic of different insurance processing modules, were built, exposing them as web services. Therefore, the individual modules were able to communicate with each other with minimum integration concerns. By adopting SOA, the applications used a common language. And I hope you're guessing already, the common language, and as the slide states, will be XML. In message transmission and hence systems such as the .NET-based insurance policy handling system in Chang & Co. was able to communicate with the Java-based applications running on Insure Company, the other company. By implementing a service-oriented solution, the system at Chang & Co. was able to merge with a lot of other legacy systems with minimum integration overhead. When studying typical service-oriented solutions, we can identify three major building blocks as follows. Now I'm going to take them step by step. Now first we have web services. Web services are the individual units of business logic in SOA. Web services communicate with each other and other programs or applications by sending messages. Web services consist of public interface definition, which is a central piece of information that assigns the service an identity and enables its invocation. The service container is the SOA middleware component where the web service is hosted for the consuming applications to interact with it. It allows developers to build, deploy, and manage web services, and it also represents the server-side processor role in web service frameworks. A list of commonly used web service frameworks can be found at wikipedia.org wiki list of web service frameworks. Here you can find some popular web service middleware such as Windows Communication Foundation, Apache CXF, Apache Access 2, and so on. Apache Access 2 can be found at the accessapache.org site. The service container contains the business logic, which interacts with the service consumer via a service interface. Next, we'll look at mediation. Usually, the message transmission between nodes in a service-oriented solution does not just occur via the typical point-to-point channels. Instead, once a message is received, it can be flowed through multiple intermediaries and subjected to various transformation and conversions as necessary. This behavior is commonly referred to as message mediation and is another important building block in service-oriented solutions. Similar to how the service container is used as the hosting platform for web services, a broker is the corresponding SOA middleware component for message mediation. Usually, Enterprise Service Bus, ESB, acts as a broker in the service-oriented solutions. Let's take a look at composition. In service-oriented solutions, we cannot expect individual web services running alone to provide the desired business functionality. Instead, multiple web services work together and participate in various service compositions. Usually, the web services are pulled together dynamically at the runtime based on the rules specified in the business process definitions. The management or coordination of these business processes are governed by the process coordinator, which is the SOA middleware component associated with web service compositions. Simple Object Access Protocol, SOAP, S-O-A-P, can be considered as the foremost messaging standard for use with web services. It is defined by the World Wide Web Consortium as well. SOAP is a lightweight protocol for exchange of information in a decentralized distributed environment. It is an XML-based protocol that consists of three parts: an envelope that defines a framework for describing what is in a message and how to process it, a set of encoding rules for expressing instances of application-defined data types, and a convention for representing remote procedure calls and responses. The SOAP specification has been universally accepted as the standard transport protocol for messages processed by web services. There are two different versions of SOAP specification, and both of them are widely used in service-oriented solutions. Now, the two versions are SOAP v1.1 and SOAP version 1.2. Regardless of the SOAP specification version, the message format of SOAP message still remains intact. A SOAP message is an XML document that consists of a mandatory SOAP envelope, an optional SOAP header, and a mandatory SOAP body. Now, the SOAP envelope is the wrapper element which holds all child nodes inside a SOAP message. The SOAP header element is an optional block where the meta information is stored. Using headers, SOAP messages are capable of containing different types of supplemental information related to delivery and processing of messages. This indirectly provides the statelessness of web services, as by maintaining SOAP headers, services do not necessarily need to store message-specific logic. Typically, SOAP headers can include the following: message processing instructions, security policy metadata, addressing information, message correlation data, and reliable messaging metadata. The SOAP body is the element where the actual message contents are hosted. These contents of the body are usually referred to as the message payload. So let's take a look at the alternatives to SOAP. The first one would be REST. Due to the complexities accompanied with the SOAP model, representational state transfer, REST, architecture has emerged as a result. RESTful web services can be considered as a lightweight alternative to the bulky and complex SOAP-based web service standards. In RESTful web services, the emphasis is on point-to-point communication over Hypertext Transfer Protocol, primarily using plain old XML or POX messages. Then we have JavaScript Object Notation, JSON. This is a lightweight data exchange format similar to XML. It is based on a subset of JavaScript language. JSON uses key value pairs to represent data which are carried inside the message. Web Services Description Language. WSDL is an XML format for describing network services as a set of endpoints operating on messages containing either document-oriented or procedure-oriented information. The operations and messages are described abstractly and then bound to a concrete network protocol and message format to define an endpoint. Related concrete endpoints are combined into abstract endpoints or services. In simple terms, WSDL provides a formal definition of the web service through abstract and concrete definitions of the interface. If we consider two SOAP processing nodes, the communication pattern between two entities can be defined as Message Exchanging Pattern, MEP. The primary message exchanging patterns are 1. Request response, and 2. Fire and forget. In a request response pattern, when a source entity, or in other words a service requester, transmits a message to a destination, the service provider, the provider should respond to the requester. This is the most commonly used message exchanging pattern. Upon receiving the SOAP requested message, the service provider responds with a SOAP response. When a response to a request message is not expected from a web service or a service provider, it is known as a fire and forget message exchange pattern. For example, if we send a ping request to a web service, we do not expect a response message back. SOAP faults. Faults can be returned by web services due to various reasons. For example, if the request message does not conform to the XML schema of web service, the service responds back with a SOAP fault. The SOAP fault element is used to carry such faults occurred during web service communication. This element must be included inside the body of a SOAP message. A typical SOAP fault message consists of the following child elements. First of all, we have fault code. The fault code element is used to define the type of fault. For example, if the problem of message transmission is due to the server, the associated fault code is server, physically. Similarly, we can use version mismatch, must understand, and client errors codes as appropriate. The second one would be fault string. The fault string element is intended to provide a human-readable explanation about the fault. Then we have fault tactor. The fault tactor element provides an indication about the responsible party who caused the fault to occur in the message path. Detail. The detail element is used to carry application-specific error information related to the body element. For example, if the payload of the SOAP request is unable, cannot be processed by a web service, the associated response should include the detail element inside the SOAP fault. Now let's take a look at some approaches of testing web services. Web services are loosely coupled and autonomous components, which are individual units of business logic in SOA. This facilitates a distinguished approach for testing web services. Because of the loosely coupled nature, the services do not maintain tight cross-service dependencies with each other. Therefore, once a particular web service is implemented, it can be tested independent from others. This gives the ability to testers to follow a component-level testing methodology. Before moving into various integrations, a web service can be tested to verify both functional and non-functional requirements. Once the service is enhanced with different attributes such as security policies, then such a service can also be tested individually to ensure that it functions properly before taking the integration scenarios into account. This gives great flexibility for testers and provides agility to testing processes. So the common approaches we can identify for testing web services would be unit testing, functional testing of web services, integration testing of web services, performance testing. So let's take a look at each of these in a little bit more detail. Now, unit testing. A web service is a unit of business logic and it consists of one or more operations. These operations must be tested individually in order to make sure the intended business problems are addressed by web service operations. Therefore, similar to how individual methods in a computer program are tested as units, web service operations must also be unit tested. Unit tests can be developed using unit test framework associated with a programming language, which is used to implement the web services. For example, if web services are written in Java, JUnit framework can be used as unit testing framework. Generally, it is the responsibility of the author of the web service to write a sufficient number of unit tests to cover the logic of the web service operations. Then functional testing. Once a web service is deployed in a service container, it is subjected to a comprehensive functional verification. The purpose of functional testing of a web service is to ensure that the expected business functionality is given by the web service. There are many approaches to perform functional testing. Then let's take a look at tool-assisted testing for functional testing. The primary object of using tools for web service testing is to support the automatic generation and submission of web services requests. As the web service interface is a machine-readable XML document, it is not an easy task to read the WSDL and derive tests manually. Therefore, tools can be used to point to the WSDL and generate the corresponding request automatically, so that the testers can send them to service with or without alterations. SoapUI is a good example of such a testing tool, which can be used in functional testing of web services. Then using a client APIs provided by service container middleware, the life of a web service is given by the service container middleware, where the service is hosted. Usually the middleware providers ship the associated client API libraries, which can be used to invoke web services programmatically without using any third-party tool. Let's take a look at integration testing of web services. Web services do not essentially run alone. Instead, they are integrated with multiple components such as brokers or service coordinators. Once a service is integrated or joined with another component, we should carry out tests to make sure that such integrations do not break the system. For example, in a service-oriented solution, if a service consumer application sends a message to a web service, but the message does not conform to the advertised schema of the web service, in this case, the web service usually responds with a SOAP fault. However, if we want to take such a request and transform the request SOAP message such that it is valid according to the schema, then we do not want to ask the consumers of our web service to change the client applications as the service schema is modified. This type of message transformation is achieved by using a broker component, in other words, Enterprise Service Bus, ESB middleware. According to the transformation rules defined in the Enterprise Service Bus, the request is converted into the correct format and forwarded to the web service. This is a typical example of web service integration. In order to test this type of integration, the request message should be forwarded to the ESB component instead of directly sending it to the web service. Tools such as SoapUI can easily be used to send messages to desired target locations appropriately. Next up, we have performance testing of web services. Once we are satisfied with the functional aspects of the web service, it should be tested thoroughly for performance. This includes load and stress testing the web service as well as measuring the performance under various conditions. We can use various open source or commercial tools in web services performance testing. Apache JMeter is a good example of an open source testing tool which can be used to test web services. The functional test which we create on SoapUI can easily be extended to test the performance of web services. Now, we have some common challenges in web service testing as well. So when compared to traditional testing approaches, there are some unique challenges associated with web service testing. First up is the use of external web services. The autonomous or loosely coupled nature of web services introduces a greater level of scalability and extensibility to the system. All services included in a system are not necessarily built in-house. Some web services can be developed and hosted by third parties. These services can be dynamically discovered and used according to the business requirements. Though this accelerates the delivery of solutions, testing such a system becomes complex because the quality assurance and availability of the third-party services are out of your control. Next up is implications of using complex standards and protocols. Web services, especially SOAP-based services, can use various WS specifications. When testing web services which adhere to specifications such as WS security, the tester should possess a fair amount of knowledge about the standards and concepts to carry out testing effectively. This introduces a higher learning curve for testers to get started with the testing of web services. Web services can also be exposed over multiple transport protocols. Thus, testing is not limited to one particular transport such as Hypertext Transfer Protocol. The same web service can be made accessible over transports such as JMS or VFS, which requires changes in this testing setup as well as different set of test scenarios. Then we have the headless nature of web services. In traditional web application testing, test scenarios can be identified quite easily by studying the graphic user interface of components. The operations of web services are exposed to the outside world via machine-readable service contracts, such as WSDLs. Thus, during the early stages of web service development, testers need to use WSDL as the reference for the derivation of test scenarios, which can be difficult as compared to exploring a graphic user interface.